You're watching The New Stack Makers, a podcast for people who develop, deploy, and manage at-scale software. For more information and articles about at-scale technologies, please visit thenewstack.io. Now enjoy the show. Hey everyone, I'm here today with Sudha Raghavan, who's a Senior Vice President for the developer platform at Oracle Cloud Infrastructure. How are you?
Good, thank you.
We're going to be discussing OCI, which is short for Oracle Cloud Infrastructure. And I also want to talk about the evolution of infrastructure and how that's impacted by the growing demand for GPUs and the role Kubernetes is playing with GPUs and the use cases that we're seeing, plus any trade-offs that might be emerging with GPUs. Also, and how open source really is increasingly becoming critical to the overall growth of infrastructure with GPU environments. So I'd like to just start by breaking down some things a little bit. Like, tell me about OCI and what use cases that you're seeing for GPUs. You know, I'd like to hear some about the technical challenges that you're seeing and how that is magnified when running large-scale, scale-out GPUs. And, what are the kind of metrics that you're missing? What are some of the concerns that brings? So I kind of like looking at a kind of a profile look at what's happening with OCI right now in terms of GPUs and infrastructure.
Yeah, so right after ChatGPT's release, Gen AI has been literally taking over the world. It is the fastest adopted technology today.
Yeah.
And along with that came this rush of GPU requirement. Everybody wants a GPU, whether they know how to use it or even if it is the right choice for the problem they're trying to solve. We are seeing a lot of GPU demand. Now, GPU demand, as you rightly pointed out, can go from a very small, I want to test something, to hundreds of thousands of nodes in one cluster running one job, like a big, large, bad job, training job, right? And that space has really not been explored. We have hyperscalers in the cloud.
Yeah.
So there have been 100,000, 200,000 nodes running more edge web applications, but all of them acting together and running one job for days and weeks and months to do the training is brand new. Now, that brings up a special set of requirements where we're seeing the power consumption for these things. If you can imagine, when for web workloads, you have a peak and a trough.
Right?
But these GPU batch workloads, there is no trough. Everything is running at peak all the time.
Yes.
And so the demand of power, the failure rate of the hardware, extremely accentuated.
Yes.
One node out of 100,000 nodes. So OCI is building the largest supercluster for GPUs yet. We're going to build about 131,000 plus GPU node cluster to run one job for one of our largest customers. Now, can you imagine if one of those nodes goes down and the whole job just stops? What does that mean? Have we lost all the things that have been, because these are stateful workloads. So the node has to checkpoint so often into a common distributed storage that one node going off, maybe for a few minutes, you lose what the node was doing because it didn't persist, but it's not for days, it's not for hours. And then when the node comes back up, it needs to pick up where the job is, not where it left it. So again, the state management of the overall job is very critical, very important. And that's something we haven't seen with traditional cloud-native CPU workloads. And again, with that, these nodes, because they have to interact in one job, they want to be placed close. They want microsecond level latencies acceptable only. When customers used to come with these 100,000 node requirements to us, they didn't tell us place these nodes in the same rack and close to each other. Nobody gave us those physical requirements. Now, because networking is an absolute must, we are running large scale, single workload, batch jobs that all need to work together to do one job. They all have to persist state very often into a common distributed file store. So everything from the PCI bus throughput to your RDMA throughput to the actual networking throughput inside, everything matters now. Everybody is talking about, if you give me 1,000 nodes, give it to me in the same data hall. Give it to me on the same rack. I don't want any latencies. We used to talk about latencies in terms of multi-cloud, like hybrid cloud, database to application latency. Can you make sure that that is only a few milliseconds? But now, even that is not enough. They're literally saying place it on the same rack if possible. So
let's go back to the roots of Kubernetes, right? And how it was originally architected. Mm-hmm. It was originally architected for CPUs.
Stateless. And stateless workloads.
And stateless workloads.
Yes.
So now let's fast forward to today and looking at how failover was architected at that time.
Absolutely. Resiliency was different.
Yeah. What was different and so what are you doing now to help increase the resiliency? It seems like physical location's important.
Physical location is important. The mechanisms to checkpoint data have become really, really important. So how do you connect your GPUs to a clustered file storage, distributed file storage
That's
service?
the checkpoint?
Yeah, which then allows you to do the checkpoint for the job.
So you're checking, when checkpoint means the check, and what does the point mean then?
No. So checkpoint basically means if a job is divided into 100 pieces,
right.
I tell a central piece of software, storage, whatever you want to call it, I am done with part 1.
Okay.
So if I go down, nobody else needs to pick part 1 and rerun it.
Okay.
Right? So checkpointing means I am letting the system know how much work I have done.
Is that manual?
Hopefully not. It can't be, right?
No.
When you're talking about like 100,000 jobs, 100,000 nodes running one job.
But that's kind of an addition to the Kubernetes architecture that's had to be made.
Exactly. So that's one important aspect that people are now realizing how to embed it into Kubernetes natively. Second aspect, these GPUs are super expensive. Traditionally, CPUs have not had a lot of high utilization, but they're still 10x or below cheaper than what a GPU costs. Now people are really wanting to use the GPU for the maximum power. So they're like, if my GPU finishes one job, I have 10 queued up. Don't keep the GPU idle. I'm paying for, this is not a by use. This is not your functions.
Right.
It's not serverless, right? I'm paying for the bare metal. I'm paying for that chip. I better use it the most efficient way. So we have things like queue and multi-queue, which are coming to the Kubernetes ecosystem to help you with that scheduling need. And then there is observability. Who would have thought that I would need to check the temperature of the chip on the GPU to make sure it doesn't fail? Right? I'm trying to preempt failures. If GPU is running really, really hot for a long period of time and the temperature changes, this chip is going to die. So checkpoint, reduce the workload, see if the thing recovers, otherwise pull it safely out. So new observability, new types of metrics in the system.
Because you have to safely pull it out and then make sure the data is continuing to be collected on those remaining servers.
Exactly.
Right.
So it's very, very interesting, the different dimensionality of the problem that GPUs are solving, how new features are being requested from the Kubernetes ecosystem.
And so when we were talking at Oracle Cloud World, you mentioned the need for better metrics. So you can be able to better understand the different GPUs by different, back-end makers, right? So,
exactly, different chip makers, right? And normalize that for the customer. The customer shouldn't need to do a different monitoring if you're using, we have standardized CPUs, why not GPUs? So, and we are trying.
So I think you've been touching on the challenges that come with metrics and monitoring.
Absolutely.
And how observability changes in this environment, because now it's a much more of a physical switchover in many respects. So what are you asking of the big GPU makers?
Yeah, so we work a lot with NVIDIA.
Yeah.
And NVIDIA gave us a sort of data center manager, right? They gave us software that a customer on their choice could deploy on these GPUs to help them collect those extra GPU metrics that are so important to guide their jobs to provide the right business output that these training models are expected to provide.
Okay.
So, and not only are we doing that with NVIDIA, we're doing that now with AMD. Before even they come out with their MI300, this is going to be norm. It's not an after the fact. NVIDIA is adding it after, but we're now saying this is standard pattern. Chip makers have to now provide metrics that they were not providing before, because it's important for the software that's running on it. And cloud providers like us try to abstract that from even the Kubernetes layer. So it doesn't have to know, oh, I'm running on an NVIDIA chip versus an AMD chip.
Yeah.
Right? I can query one operator interface and it's going to tell me what I need to know to run the Kubernetes job.
Is there an operator that's being developed right now?
Yes.
What's it
and
called?
So we added a thing in Oracle Cloud, we added a thing called Node Manager.
Okay.
Which helps all of these chip makers give plugins to that Node Manager as the single interface that Kubernetes will talk to in order to collect data. So my Node Manager will know what hardware it is, but the Kubernetes infra is abstracted from, Node Manager provides the single layer API, and Kubernetes infrastructure is now abstracted from the actual chip. So while I spoke about all the hardware problems, if we start exposing every hardware problem to layers like Kubernetes, which is already considered complex, it's not going to work.
No.
So we, cloud providers, are trying very hard to not increase the complexity of something like Kubernetes, but providing the functionality that Kubernetes users are accustomed to, whether it's through kubectl, all your known interfaces, we will just provide more stuff because now you're running on a GPU. Right. And another very interesting thing, when Kubernetes ran on CPUs,
right,
they didn't, and they said launch a cluster, nobody told you, oh, I need these CPUs to be close to one another, to be next to where my data is. Nobody gave you all of those clues. They just said launch the cluster and whatever VMs you have or bare metals you have. That's part of my tenancy. Right? Now, they're actually telling us. So we are adding inside our Kubernetes interface ability for customers to provide placement information.
Okay.
So place me next to this job. Place me next to this cluster. So we're adding all of those. You don't have to. If you're running a small job,
right,
you don't have to. But people that are running even
so all these things are being added into the infrastructure software environment.
Exactly. Yes.
And they're needed because to be able to have to monitor every instance, for instance, would just be overwhelming.
Yep.
And so now what you're asking the software developer to do is add these plugins, or is that the hardware makers who are adding?
The hardware makers are adding the plugins. The software people are asking for the data to control their software.
And then that's monitoring then different things like temperature or
the PCI fabric, what's the throughput of that thing?
Right.
Did a GPU node fall off an RDMA cluster? Right, so they can monitor a variety of metrics, but we are providing a uniform interface.
Let's shift a little bit into discussing the pipelines themselves and how they're configured, right, with GPUs. And because that's a big part of what you're doing, right?
Absolutely.
Because if you're running clusters of 130,000, nodes, right? or even 20,000 nodes.
Yeah, it doesn't matter.
That's huge. And so I'm curious on, how that forces changes in event-driven architectures, for instance.
Yeah, so many years ago when ETL pipelines came in, event-driven pipelines, right, for data processing.
Yeah.
This is just a very similar analogy to those pipelines, except now we're talking about a lot more data, a lot more need for optimizing the hardware, because previously we used to optimize a lot of software, like give me fastest possible, slowest latency, near real time. Now it is all about, I want to use the GPUs very, very efficiently. I have only 3 of them, but use them at 95% utilization all the time. It's very different constraints. So we have things like Kubeflow. LangChain was already there in this AI/ML space, trying to orchestrate. So at what point does...
And Kubeflow, for people who may not be familiar, is the tool to manage AI/ML pipelines?
AI/ML pipelines. So everything from training to augmentation, right? RAG pipelines, your inferencing, and finally the feedback loop. Right?
Okay.
So when you do generative AI and something doesn't work as expected, people are giving you feedback, and the model needs to learn from that feedback as well. So all of this is taken care in one unit and one framework called Kubeflow.
Okay, yeah.
So that is the pipeline, and I just heard a stat yesterday that 47% of people who are using Kubernetes for AI use Kubeflow.
Interesting. So then when you think about the real deeper use of data in these pipelines, and in these workflows, and the increasing amount of applications that are pulling in data, how do you see then DevOps and data science starting to intersect?
Yeah. So that's a very good question, right? MLOps. You wouldn't have heard of MLOps as this big thing until Gen AI came up, right? So we're looking at now giving you a seamless experience. So you know how Spring Boot Java came up when there was web applications. Then Ruby on Rails came up to provide more edge applications.
Right.
Now we're looking at, how do I provide as a developer platform, especially in the cloud, what do I provide for the newbie? I just want to test out Gen AI. I don't want any details. Give me the smallest possible thing for me to try out things. I don't want to do a lot of operations, don't want to do a lot of maintenance, but I just want to say, run an inferencing algo on a very popular open source Llama model. Can you host that thing for me? I will give you these many billion parameters. This is the model that I want to use. Things like Hugging Face has a model registry. So I just pick one of those and say, run this for me. I'm only running inference. I don't want to do any training. Just run that and provide me with the operations that I need to see. Is the model running? That's the basic thing I want to know, right? And is it providing, what's the feedback I'm getting? So we are looking at ML Ops as an extensibility portfolio to regular observability. Don't treat them very, very separately. The other aspect that we were talking about, how power and networking usage and all of that has become. The people who just want to try out, who don't build hundreds of, large clusters with hundreds of nodes, they don't need to know the complexity.
Yeah.
Right? So ML Ops has to actually, in our opinion, for the smaller guys who don't need very specialized hardware infrastructure, just needs to work with the rest of their observability portfolio. Whatever tools you're using, in order for you to monitor your applications, you should be able to use the exact same things to monitor your ML training and inferencing applications. No difference. But it's not there today.
And so when you think about DevOps and data science, you have to start thinking about things like CI/CD, for instance?
Yeah, so that's a great question. In fact, inside Oracle, obviously we're building a lot of generative AI services, and so we have this concept of what we call internally an AI studio, which is a platform that allows you to quickly set up everything from your model training infrastructure, serving infrastructure, data governance piece. Data provenance and governance is very important because you don't want to spread the data. How do you do compliance over this data set? What is your inventory of all the generative AI services? If a team, we are an enterprise, we have over 40,000 Java developers. If somebody in the company has built a solution, just reuse that, don't go rebuild. So we're providing an AI registry for Gen AI registry for all the services that come in. So we are platformatizing, and we strongly believe in something like an AI studio. Once we are able to use it internally, it will be a no-brainer for us to release that to the public. But we first always try to build it for our own use cases, dogfood it, make it perfect, and then release. And that's exactly what we're doing for the AI workloads.
Is it much different than a CI/CD workload for a web app versus an AI?
It is quite different because we were just talking about how expensive it is to just stop a node.
Yeah.
Now imagine I am pushing in a new model and that it has some regression.
Yeah.
How fast? In the regular CI/CD workflow, you deploy and then you roll back and everything is fine.
Right, can you roll back?
You should be able to, don't get me wrong, you should be able to, but at what point? Because deploying one node in 130,000 nodes is not going to give you enough telemetry to be able to say this thing is going to work or this thing is not. Now, if you go to 50% nodes and it fails, you've just cost me so much to do a fail. So it is absolutely possible.
But it's expensive.
But it's very expensive, and so we are trying to do it as early in the pipeline as possible. Do you really need to take the next model that came to that production large cluster? Where all can you test it in between to give you the highest level of guarantee that it's not going to need a rollback?
That's a big part of things, isn't it? It's just trying to prevent the failures themselves.
Yes.
How does that relate then to Kubernetes scheduling? Because, and I'm curious so much in hearing you discuss this about cluster management overall. Like how are these new AI workloads affecting cluster management and scheduling?
So we were just talking to a customer of ours. Cluster management is very, very interesting. Actually, fleet management, to be even more specific, right? So imagine you're a company that is running a GPU cluster of 1,000 nodes, not too large, not too small either. You run one training job on it. The training job completes, takes whatever weeks, days, whatever it takes, it completes. Now I want to run a bunch of inferencing workloads because that's my business. On the same cluster. I do not want to redo the infrastructure. But then the characteristics of 1,000 nodes running one job versus the same 1,000 nodes but running 100 jobs, very different. And now you have small, but so cluster fleet. If you say cluster management, it's still one cluster. So that's not too different. But if you say fleet management, now, in the previous case, I had one fleet to manage. Now I have 100 fleets to manage. And both the configurations, what I look for when I see failure, they're both different.
Well, just in conclusion, I'm curious about looking forward. And I'm curious about what are the trade-offs you're needing to think about as you move forward with the scale-out architectures on GPUs in Oracle Cloud Infrastructure and how that relates to the Kubernetes community.
So for us, it's all about sustainable scalability. There's so much demand today for GPUs. And as I started this, I was saying, whether you want it or not, you want one just in case.
Right.
With the market going at that rate, we want to be able to provide customers with the ability to do that, but in a sustainable way, meaning the power usage of this thing. being able to run efficiently. I was talking about how everybody wants to use 95%.
Yeah.
How do you get the infrastructure that's always by default doing that?
Yeah.
Last but not the least, how do you provide the business value that you're wanting from this Gen AI? Like, using Gen AI is cool, but at the end of the day, if it's not adding to my P&L, it's not going to work for long.
Right.
So how do I get from, okay, I got these GPUs, I got these models, they work great, to, now, because of that, here's the value I'm getting. We need to make that cycle very, very quick.
So that's the challenge, and how to do it quickly. And then I would expect then the trade-off is like, how do you, what do you do to make it quick but not fail?
Yes, make it quick, not fail. Be very flexible. So you can run a 10-node GPU cluster without a lot of overhead, but you're also able, with the same cloud provider, to run a 100,000-node cluster with all the nuts and bolts that you need to care about, because now it's such a big cluster.
So do you have to make trade-offs to your pipelines to get that quickness, but also to get that velocity, but without failure? What are those things that you can safely say, we can trade this out?
In my opinion, the trade-offs to figure out what model to use for what business problem. Do you use a SLM and LLM? If you use an LLM, do you use a 1 billion parameter which can run on CPUs, you don't need GPUs? Do you need 7? Do you need 400? Right? How do you make that decision? I am a business owner. I want to solve this business problem. Don't make me pick what is the right AI model to run for my use case.
So in some respects, the trade-off is just thinking it through a little bit better.
Thinking it through a little bit.
And not just
ahead.
going with the biggest parameter,
It might not be
LLM.
needed at all.
And if you do that, you got to understand, it may take a little longer, but if you use an LLM with a lot more parameters, you may face a failure that you don't want to have.
Exactly. And it's, again, business domain dependent. Text summarization does not need a 405 billion parameter model.
Right.
Right.
This is an interesting ongoing discussion. So.
Right. And and how can we as cloud providers help our customers choose the right thing?
That's interesting. Sudha, thank you so much for taking the time. I've really enjoyed the conversation.
Likewise. Thank you for having me in your show.
If you like this video, please give us a thumbs up. And if you'd like to see more videos like this, you can always subscribe to our YouTube channel. We're on all the major social media platforms. You can always find us at thenewstack.io. We hope to see you soon.